Hello. The topic of today's presentation is how to use the NVH Analyzer system with the plug-and-plug light, accelerometer and a measurement microphone. So since November 2025 we deliver the NVH Analyzer Pro software with license protection key, a USB dongle. So after you get your hardware, so you will get from us download link for the NVH Analyzer software via email. So this is now here this address. So I just hit it, so it's now already downloaded. And now I just open it and copy it and put it here onto the desktop. Ah ja, okay. So after you unzip this folder, you will see here this datas. So because this is downloaded from the internet, there are kind of security issues appearing, so that we have to tell here run anyway this application. So next we will start here with the 2-channel audio device. So it can be the plug-and-plug light or the Roga DAQ 2 or any other device which gets the data via the sound card API. So now I say here start. So just agree. So this I cancel. This is no needed. And this I will close. So the plug-and-plug light is recognized by this PC as a USB audio codec. For this reason that's okay. I just say apply. Now you see that he say no SG log. That's correct because it is not connected to the PC. So now I connect the USB dongle to any USB port of your PC, and if this is available, so then the application runs through. So now here for the initial test and for the initial short getting started training, just choose here the vibration order analysis and acoustics modules. So now as first we get here this window. So typically we can set here the size of the ring buffer, for example to 600 seconds. So means you can record close to 10 minutes raw datas. So which go into the ring buffer. So for example, here we can get more, for example 3600 seconds. So the sampling frequency of the plug-and-plug light is at this moment 48 kilohertz. It has a range input of 5 volt. So at the channel number 1, let's say you get the ME19 microphone. It has a sensitivity of 50.5 millivolt per Pascal. So for this reason, this is crucial to choose here this value Pascal. So if this is here not selected, so then in the another tasks we will not see, we will not be able to see the values in dB. So because for dB calculation of the sound pressure level, we need as a reference here the 20 micropascal as 0 dB reference value. So if this is here not the case, for example volt, so then we will be not able to see the dB values. So at the channel number 2, I have here the accelerometer, the U1 to 2 E.6. It has 100 millivolt per G. So I key in here the value of meter per square second. Yeah. So this is 98. So and here meter per second square. So this is here the correct explanation. But this is not offset. This is here. The offset is 0. So now in this menu we can adjust here the FFT lines resolution. If we need higher FFT line resolution, so then we can go here to 6401 FFT lines. In this case we get here 2.9 Hz FFT line resolution. So we have here several features like FFT waterfall. So the FFT should be calculated AC coupled, so that means a DC offset from the sensor or from the DAQ hardware will be suppressed here. So we have here for order tracking analysis, we can enable here the RPM detector, so that we can say, for example, from 500 RPM to 1200, from 12,000 to 12,500 RPM, the trigger should be active and acquire the data between these two borders. So here you have settings for the order tracking analysis. So, but this is not now needed. So next, if we want to see the values in vibration displacement, vibration velocity, or acceleration, so then we need to activate here this checkbox, and for acoustics this checkbox. So this is here the acceleration, this is here the velocity, and this is here the displacement. So peak values and RMS values we can use here also. So here in this window for averagings we can use here this preset averaging times, or if needed, for example, if you make a very low frequency analysis, for example for averaging of 3 seconds, then you can change this here to this value to 3000 milliseconds. But here for this presentation this will be here okay. So next we have to say the detector which channels should calculate what. So we have at the channel number 1 the microphone. In this case we make here the acoustics, and for channel number 2 we make here the displacement, the velocity and the acceleration. So this is here now so far prepared. So now I will exit here, because I like to shrink here the window and now expand this one here. So now we are in the graph section. In the graph section we can say, okay, I have here one microphone and one accelerometer. Now I like to see the time signal, the waveform signal from each channel, and from each channel the FFT. So now I go here to display, and then here I change the number of the displays. So I can choose, for example, this arrangement. So oh, okay, I don't want to have this arrangement, I want to have another one. So now again, change number of display. I choose this here. So now, okay, apply. So this is now here this arrangement. So now I want to have at the channel number 1 and at the channel number 2 the ring buffer signal. So that means it is not a oscilloscope function, it will be more a chart recorder function. So I go now here again to signal number, and here I can choose signal ring buffer. And here also signal ring buffer. This is now from channel number 2. And this will be here also channel number 2. So here in the second window I like to see the FFT. So, and here from channel number 4, in this window I want to see also the FFT spectrum. Apply. So now if I start, then we will see something. Yeah, so okay, so now we can use here several X and Y definitions for the display. So let's say the signal ring buffer, because I don't know what kind of signal is coming, please use here Y autoscale. So for this signal also Y autoscale. So then the window time, the x-axis, please show me, for example, 120 seconds. And the grid distance is, for example, 20 seconds. So, and this is also for channel 3. So now, here the FFT spectrum I have at the channel number 1. I like to see the data, let's say from 0 Hertz up to 10,000 Hertz. So then here the grid distance is, let's say, 1000 Hertz, that's okay. So because I have here on this channel a microphone, you can show this here in dB values and start at minus 20 dB. And the maximum is 140 dB. So the measurement microphone have SPL, the maximum SPL limit, sound pressure limit of 130 dBs. So then let's go here to 140 dBs. Up. So at this channel I have here the accelerometer. So then here it's again same. Let's go to 10 kilohertz. And here the grid distance is 1000. So let's leave this linear. And here I don't know what's coming. That's why I make here the Y auto scaling. So I think the okay. So now we can see already that here it looks different. So now I start again with the measurement. So this is here interesting. We can see here some peak. Maybe here from the AC/DC converter or something like that. This one here. So now we get here our signals, and I have now the possibility to export this data. So means if I once click here to the window and then hit the alternate key and G for graph, I can export this graph data into the CSV format. So here I can adjust the needed definitions. So this is same here for the FFT spectrum. If I'm now in this window, Alt G, so Alt G, and now I can export this here. So there are also another possibilities. If we go here to the print section, so then we can predefine here that he should output this data in a PDF document, and here I can set up the layout of the experiment. So here like this. So and now we get here this window. So here with this we can prepare all graphs, so that the graphs will be arranged here in this PDF document. So beside this, we can record also the raw data if we want. That means I make here the recording activation. Now let's go here to the desktop. So let's make new. raw data. So, and now I can watch here, and then I can record the raw data after I hit here the green button. So, now I stop with the recording. So it can happen that you record several files. So if you have the raw data, that's always good. And now I can, for example, load this recorded data. Here, load recording. This is now 9 MB file size. And now, for example, I can do following. I can say, okay, this is here ME19 and here the accelerometer. And now export this data in ASCII format. So now I can check this here. And here we see now the data already in physical units. So means you can analyze this here then with another programs. So that's all for today. Thank you very much for your attention. And yeah, this is a process how to getting started with the USB dongle system, and yeah, how to measure here with this, with your new system. I wish you a pleasant time and have a good day.